No.
Why? Yeah, Jaden, you good? Why is that? So we would say no. Each sample of 5 would be what? If I took 5 of you and averaged your beats per minute together, would it be the same as 64.5?
No.
No, yeah, because each sample is different. Good, yeah. So no, each sample is different, and again, you got to write fast today because we're going to fly. And because of that, I will give you right now 8 tickets. If you could tell me what we call this when each sample is different. Raise your hand just so I could call on you. What do we call that? Each sample is a little different. And so if I took 5 and took a new 5, each time it would have a different average. We call that what? Yaden?
Is it the sample mean?
You got part of it right. Part of it right there. So the sample mean would change, right? When it would change, we call that sampling. Oh, I heard it. Say it again. Variability. Very good, Alex. Sampling variability. Got half of it right there. Nicely done. Still got you 4. All right, now here's the next thing. Would you be surprised to learn that the true population, okay, was 68 beats per minute, and explain why you would answer that or why you wouldn't answer that. Catherine?
I think I wouldn't be surprised because the margin arrow, like the mean plus margin arrow is like included 68.
Excellent. So what was our estimate?
64.5.
Yeah, do this real quick. This is our formula estimate plus or minus margin of error. So 64.5 is our estimate, okay? Plus or minus, what's our margin of error? 5.6. So when I actually execute that, we get 58.9 and 70.1 beats per minute. Great job. So we'll do that again, 58.9 and or 2, 70.1. If I add and subtract that margin of error, okay? All right, so because of that, is our sample within the confines of my estimate plus or minus my margin of error? Yeah, so are we surprised that? No, we are not surprised, right? So we would say no because it falls in my range of my estimate plus or minus my margin of error, okay? So you could just say it falls in my range of my estimate plus or minus my margin of error, okay? By the way, as we go through this, we're going quick. Stop me if you've got a question, okay? Part of this is just kind of engaging, making sure we got it, and then we're going to execute the actual experiment here in just a second. All right, here we go. How could Coach Jay find a sample mean that is closer, raise your hand now, to my true population? What could Coach Jay do to find a sample that would explain or be closer to my true population? Alex?
Could you increase the sample size?
Bingo. Increase. Nicely done. Increase sample size. Increase sample size. I actually talked about that today in our probability. Batting average is a good predictor of that. It's kind of the same thing, right? So it will go closer to my true population as I increase my sample size. All right, number 5. Are you staying with us?
Yes.
All right, good. Hopefully this is helpful. Coach Jay will give you a beverage to drink. We will in a second, okay? Coke. That sounds bad. Never mind. Forget it. That doesn't sound good. Drink the entire beverage. Is this an observational or an experiment? I don't like that question. Let's say that I will randomly assign you into 2 different treatment groups, one with caffeine and one with non-caffeine. Experimental or observational?
Experimental.
Experimental. Could someone tell me why, Sydney? Why would it be experimental?
Because one group will have a treatment and the other will be a control group.
Okay, so we actually, in this context, am giving either caffeine or caffeine-free, right? So is there a control group here?
No.
No, there's 2 what?
Go to 3 treatments.
Yeah, so 2 groups are compared. 2 groups compared. Caffeine, non-caffeine, no control group, okay? Those that have max up, make sure we're still with us, cool? And when we have those 2 groups that we compare, there are 2 treatment groups, right? One with caffeine again and the other non-caffeine. We also randomly what? Assign, that's a huge thing, okay? All right, randomly assign there. And there was one other thing I wanted to show. Oh, yeah. So if I have caffeine and non-caffeine, one is obviously the treatment of caffeine. Can someone describe to me what non-caffeine would be? John Michael? Placebo. Good job. And because of the fact that it wants us to take away the placebo what? Effect, right? So non-caffeine is a placebo. The placebo effect is when you think that it's actually helping you when in actuality it's not because of the actual thing you're taking, but because you actually think it. Yes, Jake.
I was just gonna say, was this a double-blind procedure?
It is not today. Can anyone tell me why that we couldn't do it double blind, Brianna?
You know which is which.
Yes, and if I didn't know, then that would be a problem because I wouldn't be able to, in this context, tell what was going on, right? All right, good. All right, we said this was blinding use for this experiment. Yes. All right, Chloe, the birthday girl. Let's see if you've got this one. Why is this important? Why is, like, in this context, if we have a caffeine, non-caffeine, right, half and half, why is it important for this context to be blinded, you think?
Because like if someone knows like who has caffeine and who doesn't, then it can mess up.
Yeah, it could mess up, and those that drink something and those that don't, it's like, okay, if you think you drink something and you're the only one that drinks something, then ultimately that's a placebo effect or possible, right? So we would say yes, and I want to get down what I had said earlier. So we would say it's single-blinded because we want to make sure that participants don't know what they're getting so that it doesn't negatively impact the experiment, okay? So we'd say it's single-blind, and we could put like placebo effect. We don't want to, how can I word that? We don't want to have the caffeine negatively impact the study. That was awfully written. I'm so sorry. I would say this. I would say we don't want the caffeine to negatively impact the study based off the placebo effect. So that's why we've got to have the non-caffeine drink. Okay. I should have said that differently, but we'll work with that. All right, number 7. Describe what a confounding variable is and list a few that are that may affect our results. Anyone want to try to take a stab at that? Sarah, you got it?
Maybe if there's like a disproportionate amount of like females versus males, maybe there's like a difference between heart rate just between the two genders.
Ooh, yeah. So like females, males, heart rate. That's down your alley, right? Aren't you wanting to be in the medical field?
Maybe, I don't know.
Okay, I thought we've talked about that.
I'm just throwing out a bunch of majors.
I feel you. I love that. Let's go. Alex will come around. What's another confounding variable?
You have something like sugar that can also raise heart rate.
Say that again, Alex.
Something like sugar, which is both things that can also raise heart rate.
Yeah, so sugar could, right? Sugar, depending on the sugar consumption. I like it. Good, Catherine.
Maybe each person's different sensitivity of caffeine.
Yeah, the sensitivity to it. I like it. So there's a lot of these, right? Jade, you got one more?
Yes, I was gonna say, people might, like, okay, shoot, what was I gonna say? Oh, that thing about like what we watched the video on, like some people might just think that their heart rates are higher, so they might kind of count, because like they might count wrong.
Yeah, that's really good. Yeah, I think I got you one, right?
Yeah.
Yeah, that's exactly right. Maybe they counted wrong, or it was just the way that they went after it was different. I agree. So confounding variable, just a heads up. We've talked about it, just a definition. This kind of helps us. It's a variable that impacts the what?
Results.
Yeah, response, results. Actually, response is good. There, Lindsay, that's probably good. Impacts the response. And is not what? Say that again. Kind of like that. Good, Chris. We say in an experiment, if it's not biased, then in that case, we would say it's not controlled, right? Good. So it is not controlled. Nicely done. Who said control? Good. Nicely done. Good. Questions on that? All right, good. That's a confounding variable. That's what we're looking at, okay? Next one. If we really just want to see if caffeine increases heart rate, why can't we just have one group who all drinks caffeinated Coke? What is the problem with this? This is kind of towards inference here, Brianna.
You wouldn't have control, like you wouldn't have anything to compare it to.
Bingo. That's it. No
Good job, Brianna.
comparison. 2 seconds. Did you just say something nice, Jake?
Yes.
Miracles happen. Love it. Miracles happen. All right, here we go. Let's keep going. Number 9. Are y'all good so far?
Yes.
Is this at all helping? Okay, good. Good, good. All right, here we go. Identify the following. So I would say yes. Explanatory variable. What is the explanatory here? Hey, Chris? Oh, was it Alex
Yeah.
speaking over you? What was it?
Caffeine.
Caffeine. Good. Caffeine. Someone who hasn't gotten a ticket today. What was the experimental unit? Shane?
For the experimental unit,
Yeah.
I was going to answer response variable.
What's the response then?
Heart rate.
Heart rate. Good. So we got heart rate's the response. Caffeine's the explanatory. Does anyone know what the experimental units would be? Lindsay? Okay, yes, it's y'all, right? Students, right? Students? Really? AP Stats? Students? Holla at ya.
Yeah.
Holla at ya. We are G to G.
Hold on.
Experiment. What's that?
Yeah.
Not my way.
No, that's
Holla.
that says Ola.
True. Holla. There we go. Also, I heard someone say experimental units is subjects. Why would it be subjects?
People.
Because they're people. Good. Nicely done.
Oh. She should have still.
Oh man, wow. Treatments. What's treatments? John Michael?
The caffeine and the placebo.
Caffeine, placebo, or you could say non-caffeine. Either of those two are appropriate. That's good. The second one, number 10, going to number 10. How could we randomly assign the students into 2 groups? Now, before we do this, let me first tell you this, okay? Because right now we're going to go through a couple things. Once we get to a few questions, we're going to actually execute it, and it'll get better than just us talking, okay? But I will tell you this, that you need to make sure you describe this. Tonight, here's what I would do to study, okay? Call someone up in this class or in the 3rd period class and just say, hey, could we just talk through real quick, how would I describe something like this? Because I will tell you, some of you know what you're doing, but describing it is the difficulty,
Yeah.
okay? I'm the same way. I had the same troubles when I was in high school. I had a hard time putting it down. Practice that, okay? That's what I would do. All right, how would we randomly assign the students into 2 groups? Jaden, go.
You could give every student in here a number. How many kids are in here? I don't know. Okay.
Number of
0,
students?
Yeah, it's like 0, 1 through however many is in
2. I
there.
think there's 15 today. 3, 6, 9, 12, 15, 16. My
Okay,
fault.
16, and then you could use table D.
Yep.
And then you would have to state that you're not going to repeat any numbers or use numbers out of your range.
Ignore repeats.
Yeah, and then you could do it until you got to, I guess, 6 or 8, and then the 8 that weren't chosen are the other group.
Good. And so we use table D to choose what?
The first 8 that
To
are treatment
choose first 8
1, group 1. I mean.
and put them into group what? Them into, group 1. And then there really should be one more thing, because what happens with the remaining 8?
They're put in group 2.
They're put into group 2, okay? Here's the thing. I know I'm doing bullets. Don't do bullets. I'm doing it more for quickness today. But when you do it, make sure context, put that in. Number of students, use table D to choose the first 8. Put them into group 1. The next 8 put to group 2. Ignore repeats or numbers outside of my range, okay? Questions? Is it okay to just say they were randomly assigned? No, you gotta describe it. Okay. Why do we use random assignment? Now here's the inference. You ready? Maybe you struggled on this a little bit, I want to make sure we hit on this. Why do we use random assignment to 2 different groups. Okay, I like that. So first off, it controls, and really that's the main reason, right? Controls confounding variables, such as what we said earlier, right? Which is what Chris was saying there.
Would we have to
Okay.
state the confounding variable?
I would just one at least, such as I would say, maybe context if I need it. Random assignment allows me to control confounding variables, which allows me to randomly put them into 2 treatment groups and then compare at the end. Confounding variables could be things like state 1 and then state how it could negatively impact that study. Cool? Like what Sarah said was good. Gender, how it could, depending upon the makeup of males and females, could that be something that could be a confounding variable? So, something like that. Cool. That's a great question. All right. And also it creates what? It creates equal what? Equal groups, right? Want to make sure it's equal groups when we randomly assign. Gucci. All right, outline of the completely randomized design. Make sure we know how to do this and describe it. We start with what here?
16
No.
students.
Are you going to, is that, are you gonna count that as points? Because you said that like it wouldn't count if we did that on the AP exam. So for our test, because I know I can just like pretty much jump into it.
If you can jump into it, jump into it. Got me? I do it for myself, so I hit each topic.
Because on the quiz I know you took off, like we had to do the outline.
It will. That's the only time I'll ever require that. From here on out, you will not have to. And I don't think I've ever seen them say, put the outline here. They'd say describe. And that's really all we're looking for. Great question. So we'd start with 16 students and do what?
Randomly assigned.
Random. Good. Then what would he do?
Group 1 and group 2.
Group 1 and group 2. How many in each?
8.
8 and 8. What would happen here?
Treatment 1, which would be the caffeine.
Treat 1, treat 2, caffeine, non-caffeine, and then what would I do? Compare. Now, here's the one thing I saw on y'all's quizzes. Compare what?
The heart rate.
Yeah.
And even further, the difference in heart rate, right? Compare the difference in heart rate, okay? Cool. All right, here we go. 13, 14, 13. What are the 4 key principles of experimental design? Let's put them down. I'm not going to list all the extra stuff with it. Just give me one. Compare. We've obviously got that. Number 2, random assignment. We've got that there. Number 3, control is the key to get that victor. I'm sorry, I don't know why. Replicate. Yep. And that's it right there. Number 14. Coach Shea thinks that genders may play a role in the effect that caffeine has on a heart rate. How would you adjust our experimental design? Raise your hand. Let's see if we've got it here. Brianna? Let's block this thing, okay? So this is a randomized block design, okay? So this would be a block. And does it say the next thing to do a outline? Yeah, let's do an outline real quick. What do we start with? Sample of 16. Cool. What do we do next?
Put them into girls and boys.
Good. The other class said randomly assign next. I can't randomly assign males and females, right? You're either one male or you're female. Okay? All right? We're just going to leave it there. Okay? So, we're just, today's, never mind. We're just going to, all right, hold it right there, okay? 3, 6, 9. So we have 9 females, okay? And then there are 7 males, okay? I think that's right.
6.
The other class is just a little.
Hold up, did I count wrong?
There's 6 males.
Did I count wrong?
You can just include you in it to make it an even number.
Appreciate you. So we'll do 7,
Well, it's
okay?
easy.
So then what do we do from here?
Well, there's 10 females.
Split them into.
Are there 10?
Yeah.
Oh, there are. There's 10 females. All right, here we go. I'm sorry. Okay, what would be next?
Wait, so how many
Random assignment. Okay. This is into group 1, group 2. What goes into each group for our female side?
5 and
5 and 5, make sure they're equal. We then, for the random of the guys, group 1, group 2, this is pretty, I'm sorry. What would be for the guys here?
3 and 3.
3 and 3. We would then do what with each of these?
No, treatments.
Treatment 1, treatment 2, make sure you describe it. Treatment 1, treatment 2. And then we would do what? Compare difference in heart rates. And there you are. Okay? That's a block. Is a block random?
Yeah.
Yes, but not at the
Random, but
beginning.
less.
Less random in terms of we're controlling something, and then it's almost like we've got 2 experiments going on, right? Good, good. Okay. Hey, 16 is tough. There is a question on the test on this, and then we're going to get to the stuff where we actually do things and get up and that sort of thing, okay? So, Lindsay, you got something real quick? I'm sorry, I know that's messy.
No, I was gonna ask. Do you not compare at the end all of them or no?
That's a good question. It depends. I would compare maybe at the very end. Hey, what was, after I compare these, I might compare the differences to see what happened with treatment 1 and 2 with males and then females.
Okay, because isn't the point of what we did, isn't the point of blocking so that you can compare the two? Or no?
The idea is that you're really comparing first between the males, right? What happened with treatment 1 and 2, and then females. And then once I'm done, I'll analyze what was the comparison of both blocks. Okay. All right, match pairs. What's the definition of this?
Is that like when you have in the class like the 2 highest people and you kind of just
You could do the highest heart rate.
Yes. Good job, y'all. Yeah, the highest heart rates. If you order the initial heart rates from high to what?
Low.
High to low. Okay. Match pairs is a size of block of how many? Blocks of size 2, where we take the 2 highest in heart rate, we randomly assign one to what?
one group and one to the other.
Good. So we group highest 2 together. Highest 2. 1 is randomly assigned where? Assigned to T1, and the second goes into treatment 2. Okay? And then I would keep doing the pairs all the way down until I'm done, right? Until I'm done. Cool, cool. That's match pairs. Right? Groups of blocks of size 2. All right, here we go. Now, today, what we're going to do is when I'm conducting this experiment, I'm going to have half of you go on the left side. So there's 2 groups of cups. One is caffeine-free and one is just regular caffeine. Before we do this, is there anyone that cannot participate for one reason or another? Cool. Okay, good. So when I put you over there, you got to, once you go over there, 2 things. We're going to do it all at the same time. And then the second is you can't say like, oh, this tastes like caffeine. Okay? You got to make sure. All right? Make sure you did. The other class did that. Okay? So you can't say anything. All right, you ready? All right, here we go. I'm just gonna randomly assign you over there, okay? So John Michael, I think you look more like on the right side. Alex, you're on the left side. I think you look. Lindsay, you look more for the left side. Ronald, I think you're more on the left side too. Is there a problem with what I'm doing right now?
Yes.
Y'all didn't call me out.
I did.
like,
You're the teacher.
I don't want to
Sure, everything is
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 16. Alex, okay? When you go to your calculator, this is important for the test. You're going to go to your math, okay? Math, remember this? Probability. Random integer, no repeating. Lower is 1, upper is 16, and we choose 8. And again, I would put this on an FRQ, what you see right here,
I only gave you 3.
just in case, okay? Say again.
I only gave you 3. So he didn't practice.
Oh, I got it right here. There we go. So if you're 16, if you're 4, if you're 6, 1, 15, 2, 9, and 14, you're going to come on this left side,
Good after, Steve.
okay? If you are not that, you are on the right side.
I already feel like I'm losers.
All right, hey, yo, I forgot 1 cup. This is not good. This is not good.
It's a disaster.
All right, look away. If you're on the left side, don't drink it yet. And if you don't have a cup, Just look away. This is so ratchet. This is not good. I'm telling you how not to. Who has not gotten one? Who has not gotten this left one? Does everyone have one?
Wait, if you were
Already.
Brianna, you got one?
Okay. What never before? Okay,
Alright, Brianna, you got yours? You drink it stuffed? Alright, drink it. Go. Down it. I heard that, Jade. That's really inappropriate.
As soon as I said that, I was like, that's not a fun. I'm sorry.
How did you know what that is?
Yeah.
Just got exposed there. Me? What I just said?
Does this still work?
It's that
He just pressed it.
Wow.
Wow.
This is so
Is that right there? You know what that switch is? What is it? Switch, right?
It's PA switch, right?
Oh yeah. Don't. It's connected.
I thought there was some info on the white.
So if I press it, they can
Oh yeah. No, well, they'll hear it. They'll hear it. They can hear it in our class and stuff.
I'm not sure.
Usually Coach Woodard will come over here and himself. Make sure. It's like if something went down. Yeah. It used, you know what it used to be? It used to be it was in history. They had that maps and stuff where you would hit it and it would just come down and then go back up.
That's you and my data jumper. Could you not speak the button?
Just press it across. Yeah, that was the
Because there was something there when my classroom was first over here. Maybe it is, but I don't think it's connected to that. All right, are you ready? Hold up, down it, bottoms up. Let's go. Drink it. Yeah, drink all of it. Gotta drink all of it.
That's because you don't have this one.
I know.
Am I drinking coffee?
This is not casual right now. Like, whew.
I'm pretty sure.
Yeah, we're all. I haven't.
Go like.
Sorry, it's not a joke, right?
I'm in disgrace.
All right, we're gonna do our heart rate in like 30 seconds.
I've actually been
Time after drinking as a confounding factor.
Technically, you need to be like everyone down right away. Because now theirs may be affected differently. Kristen's got like one sip. I'm like,
We all.
Oh, this is cola.
I think this has a negative effect on heart rate.
is it spiked up?
No, my heart rate's going down.
Oh, it's going down?
Yeah.
Like
Oh,
calming?
he put sedatives.
Well,
Everybody drops. This is like that. I was like, boy, 101 with it.
Alright, here we go. Ready? Test our heart rate. You have 1 minute. Ready? On the mark.
They're not listening.
I know this experiment. Let's just be honest. It sucks. Ready? Because of me, not because of you. Ready? Set.
Because that's are not organic.
Go. Count. Stop. All right, put this right now at your seat. Put it in this spot here. And then when you find the difference between your new minus my initial, I need you to come up and put yours up here. You're only one number. Your new minus your initial. By the way, if you were on the left side, you were caffeine free. If you were on the right side, you were caffeine.
Well,
I knew it. I could tell it.
What?
What up the difference there?
Wait,
My heart rate went down.
wait, really?
Yeah.
But I saw you like brought a Coke bottle.
It's caffeine free.
Oh, she cheated.
Ah.
Jaden is a cheater.
I didn't.
Wait, they were both like.
Is it
There's no
Yeah.
the other side?
I
That
Diet
we
Coke
won't say it.
in my
I didn't see it.
You're not funny.
Okay, shut up. No,
Yeah.
you're not funny either.
That's why you jump to your conversation.
I was trying to be Jaden for a day.
No. Everyone's so weird.
Jaden for Halloween.
My heart rate is 14.
14?
Wait, writing the.
Wait, am I?
Just your
caffeine?
difference.
If I was on
Your
that
difference.
side, if I was on that side.
Oh yeah, I
Yeah,
got heart
wait.
rate.
Oh, I see.
No, my heart rate. I might have not been.
I hate
What'd yours do, Shane? Went down?
Down one.
Mine started off really fast, but I think I was like talking.
Because you're an idiot. I mean, you're switch out.
I'm really curious with your project second semester if you could do like a baseball.
First of all, we
Something
don't
with
even got a
baseball.
315. Yeah.
What's the second semester project? Just think about
Whatever
it.
you want. It's literally you'll pretty much conduct. There's more to it, but you'll conduct like an experiment, and you'll then show inference with something you think could happen. So, like for instance, Matthew Marino's doing one with our basketball team. My question is does our points per game increase when we when our I could do a couple of things when we shoot more threes, like how does our how do our points per game affect? We're doing a couple different ones, but it'd be kind of cool to see, like, does your batting average, is that impacted by
Jaden, you got 0
X?
Yeah.
I don't know what you can do.
It was trying to be as many days, but I didn't know.
Now it's
What are we
just
putting up here?
different
The
picture,
increase in heart rate.
Increase in heart
different day.
100%. So you'd have to kind of, the way you randomly assign
No,
them,
you said
You'd
it
have
was
to think
2.
about
You
how we
split
can-
it out how he faced.
Matthew
No,
did
you're
a-
lying.
he did a basketball one last year. And he did NBA. No, he did Major League Baseball last year. Something with Major League Baseball, but I remember it was pretty cool.
Yeah, you're
Okay,
You suck.
all right, let's do this. If someone could get a calculator out real quick, okay? And could someone average the top together real quick, just real fast? Catherine, would you mind doing the top? Just average the top together.
16. Top and bottom.
Christian,
Just kidding, I don't have my
is this like, can I get, like average? It's like, I know,
What's going on? Is everything okay?
Seriously, like, get out of the way.
Yeah.
and I could just test that on my own.
You could, yeah, definitely. And it'll be all semester, so you'll have tons of time to gather data. I think that's the toughest part. And once you get the data and you do it appropriately, it can be really powerful. Because all these NBA teams, that's where they're moving to. Like statistics and stuff, analytics. Like in the NBA, a mid-range shot is, in a lot of teams now, do not shoot a mid-range jumper. There's only,
Carmelo Anthony did that. He got ragged on. Wait, really?
yeah.
You're in mid range.
Well,
Because it's a low percentage shot when you take the same percentage shot for 3 points.
I didn't ask for it.
it's higher percentage than a three, but the points per possession, it's called PPP, points per possession, is higher when you shoot three than if it was a mid-range
You
jumper.
know how Carmelo did the thing like
All right, here we go. Yes.
How come they're nice for cafe and always
Oh, hold up. Who did the? Hold up, real quick, up here.
Did that.
Did anybody have the caffeine-free on the left side that maybe put theirs in the wrong one?
Oh, I did.
You did. Where's yours? Where's the pen again? Do y'all see that?
We did. Sorry.
Oh, she's so She really took it off the
How do you
face.
You can just cross it off and then just put it on the side.
Did you?
What did you say?
What did you say?
So that
What are you asking about?
Oh, jeez, you mean like no secrets for me?
Okay, yeah, so you put it right on the bottom.
wait,
I pressed it.
Sarah.
Oh, no, they haven't.
Negative 2.
Good. Okay, so here's the thing. Some of you said inference stuff. We're going to have to rock and roll because we've got about 25 minutes left, and yet this is what we're about ready to do is kind of our final straw of what we've talked about for experimental side, right? We have not talked about observational much today. Again, we'll talk about that more tonight when we go through it, okay? Would someone mind, Catherine, are you doing both the top and the bottom average?
I'm doing that.
Perfect. Okay, while Catherine is doing this, I want to make sure we talk through a couple of things, and we'll go from there. Actually, let me do this here. Get these down. I think these are supposed to be on there. Make sure you get these down as I put these in. I'm going to put these in so we could see what's going on here. All right, caffeine, 14, 2. Did someone get negative 26? Is that right?
Someone also got 14, which was really high.
That's all right. We'll just go with it. It's cool.
Yeah, negative 14.
What is wrong with you?
We might want to.
We're so aggressive.
Could be. Here's a question. If I got someone who had something where it was like negative 26, I had someone in the last class do that too, so it's okay. What would you do in a real experiment?
Outlier.
I might throw that out again. Here's the question. Is this a good sample size to show cause and effect? Not really. I would increase this bad boy, okay? And we'll talk about, I was talking to Shane, we'll talk about that in the second semester, okay? Cool. All right, let's go to, all right, we'll begin that analysis, and we'll go from there. Okay, hit this. All right, Catherine, did you get that top part?
Yeah.
What'd you get?
-4.
-4? 0.00. What was the bottom one?
Negative 0.625.
So caffeine free. So what's the difference between caffeine and caffeine free?
Caffeine decreased heart rate more than caffeine.
Isn't that right? Yeah. So that kind of threw us off just a little bit. Totally went against everything we were trying to do in this experiment. Catherine, would you mind doing me a favor? Just for what we're doing, take out that 26 and tell me what you got there. If you could just do the top part.
It's still gonna be lower than.
Is it still?
I think so.
Yes.
Yeah, who was that?
Is that you, Sarah?
We're not going to point fingers. Jaden. I'm sorry. That was really mean. That was mean. That's me. Me? I'm a bully?
No.
Yes.
Oh.
She said yes.
What was the top part again?
It's now is negative 0.857.
Yummy. All right.
We're
Well.
up to 14.
That was
We're
me.
all
I'm calling you out, Jaden.
All right. Let's do this. Okay.
Let's throw out all the numbers and make you
This did not work. This did not work at all. Caffeine relaxed y'all? That's really what it's saying. I mean, yeah. I could see that. All right. Can y'all see this on my screen? I want to do
They did slowly.
there are. Okay, so I am literally doing something very unethical. I'm changing some of these. I am lying. Boo me. That's fine. Boo me. That's fine. All right. So the question is the difference. 6.66. Oh man, that's Satan coming out. I can't do that. That's bad. All right. Lord, I'm sorry. All right. This is for an example. I'm not changing.
Never changed the tab.
That's really bad. Okay. I don't even know where to go from here. All right. Okay, we're going to say around the difference of these two. Just do this just as we change it. Just put down below. All right, this is going to be our change data is 6.66. Okay. 7. There you go, 6, 7. On the bottom, this is negative 0.625. The difference of that, we're going to go to the next one here. The difference is going to be 7.7, we're just going to say. Okay. So 7.7 difference. The only reason why I wanted to show you this was the inference side of it, and so I want to make sure that's the mean of the caffeine and the mean without the caffeine. Cool? You got me on that? And then we subtracted and we're good. All right, here we go. Now, remember on the Thursday, or it might have been Friday before y'all went on fall break, we did then, what if this was just happened by chance? And what did we do? We randomized the 20 cards, right? Put 10 in one, 10 in the other. We took all those dots, I think it was right behind Alex, and then we said, does this give us enough evidence to say that caffeine caused a decrease in heart rate, right? I just want you to see this part, because with the ones that we had, the data we had, it wouldn't work out. So if I did this 50 times purely by chance, let's check it out. Let's add the trials, and this is the dot plot that would come just purely by chance, okay? Now stick with me, because this comes to inference, this comes to the important stuff. When I look at this, there are 50 total samples. Out of that 50, which, I want to make sure that's 7. So how many dots were exceeded 7.7?
2.
2. All right, so stick with me here, because this will be on the podcast if you want to go back. Really, I just want you to get it more than get it down. If you look at this, that means 2 out of 50 were 7.7 or greater. Got me? Is that statistically significant to say that caffeine causes a decrease or an increase in heart rate?
What does
Yeah.
it have to do with lessons?
5%.
So, yeah.
Yes, because this would be what? 4%.
4%.
Cool.
Ooh.
Since it's 4%, how would I describe that? Well, I would say because of the fact that this would be 4%, we can assume that this is statistically significant and can say with confidence that caffeine, in fact, increases the heart rate. Right? Does that make sense?
Yeah.
Questions on that?
No.
All right, so question coming to this, because we're kind of going all over. I'll formalize this, put it down here in a second, okay? Can I infer to my population with what we just said?
No.
Good. John Michael, why is that?
Because it was just from the AP stat class.
Good. Just AP stats, right? So can I infer to GAC? I can't, right? Did I take a random sample from GAC?
No.
No, it just was y'all, right? Just the best students in GAC right here, okay? All right? And so, I'm not joking. And because of that, y'all are here. This is not a random sample, therefore I cannot infer to my population. Now, here's the difference. Can I infer cause and effect?
Yes.
Because I did what? Random assignment. You see the difference? Now, let's pretend that y'all 15 was a random sample from GAC. I then randomly assigned you. Can I show cause and effect?
Yes.
Yes. Can I infer to my population GAC? Yes, I can. Do you see that? Okay? Now, if I just, let's say we just did an observational where I didn't randomly assign. I just observed, okay? And let's say it was 15 people from all of GAC. In that context, can I infer cause and effect? No. If it's no random assignment, I can't. Can I infer to my population? Yes. And I can show correlation, but I can't show cause and effect. Thoughts there, Brianna? Did that help at all?
Yes.
A little bit? Could someone maybe explain that just a little different for those that might need just one more example? Sometimes from y'all it's better. Yes, from like random sample versus random assignment.
Like, I don't know, if you just like you just got a couple people in a room that, I don't know, let's say I got the swim team in a room, and you do your little sampling thing, you do a random assignment, like you can say cause and effect based on their results, but the swim team isn't everybody, so you can't say it's about the whole population, it's just about them.
It's perfect. Yeah. No, I love that. So like basketball team, right? Basketball team. If we were saying, does drinking Gatorade affect performance, right? And I just got the basketball team, the guys that were on the team, and I said, okay, random assignment. Half of you are drinking Gatorade, half of you are placebo. Let's see blank at the end, whatever we're trying to find. That is random assignment. I can show cause and effect there, right? What I can't do is infer that to all of the basketball teams in the state of Georgia. Because that's not a random sample. It's just GAC. If you're on the team, you're in the study. So I can't show random, or I can't show inference to the population. Cool? But if I got like 15 random guys from all the state of Georgia, randomly, however I do it randomly, I bring them in and then do a random assignment, now I can infer to my population, and I can infer cause and effect. Okay? So what are the best samples? Random samples that also have random assignments. Do you see that?
Yes.
You see that?
It was if you have random above, you can do both. But if you only have random assignment, you can only do which one.
I can only show cause and effect for whoever I'm sampling, right? But not outside of that. Does that make sense?
So
Cool.
what if you have like the whole population says, yeah.
Yes.
And then if you only have random sampling, then you could show inference but not cause and effect.
I can show, well, both are inference. I can infer my population, but I can't infer cause and effect.
Okay. Yep.
Cool, cool. How do y'all feel on that? Really, that was the podcast. Great, yes, let's do that. So over here, 20, 21, 22, and that sort of thing. What percent of the dots are larger than the difference in means? Just because it's on the podcast, let's just say it was 4%. So is the difference statistically significant? Yes. Because it was less than what?
5%.
Yes, as a result of Coach J, but nonetheless true. Yes, because 4% is less than 5 or greater, less than 5%, we can say this is statistically significant. There's a problem with this. If I put this on the AP exam, what is it? Yes, because 4% is less than 5%, we can say this is statistically significant. Just put a little context to it and you're good.
Oh yeah.
What are we talking about? The fact that caffeine does have an impact, positive impact on increasing heart rate, right? All right, here we go. Can we generalize the results to the population?
No.
No, why, Chris?
Because your sample isn't, it's a small sample, you need more of a wider range. Right?
Yes, exactly right. No, because the small sample, okay, the small sample is not what? Is not randomized and it's not representative of the population. I could take either. I could take it. Not randomized from my population. Perfect. Rockin'. Next one. Here we go.
Yes.
Can we do?
We can.
Yes, we can because
We have random assignment.
random. Yes, very good. Random assignment. Rockin'. Okay. What conclusion can we make? All right, now get this down. Okay. This makes me really happy. I really want to drink in this. And by the way, yesterday I was being observed by Mr. Beasley, and I didn't realize I didn't realize it, and I was just acting like with this. And I said, in the class, I said, oh my God. Are y'all good over there?
Yeah.
Sorry. We're going to help. Hey, let's help John Michael out. Is that on your notes, my man?
Yeah, that's all good.
Hey, let's get him some if we could. We'll take pictures of it later, okay?
No, it's
I'll
good.
send them a picture of mine.
Very good.
Wait, but what did Mr. Beasley say?
So no, he didn't. But I was like, I would never drink out of this. And someone called me out in front. They were like, "Yes, you did it the other day."
Yeah, did you not drink the other night?
No, I didn't. I didn't.
Oh, okay.
I was being
Oh.
facetious. All right, here we go. Last one. All right, here we go. This is the last thing. Was it? Yes, this is yes. Okay. Take a look at the last notes if you're confused on 24. 23 is the big one. For this statistics class, why can't I go outside of my statistics class?
Because you didn't do it.
Because I didn't find a random sample of GAC or whatever my population is. For this statistics class, we found convincing evidence that what? Caffeine
causes heart rate.
causes heart rate to increase. I will give you 10